Hey everybody, sorry I'm not around again today. Said I'll be back as soon as I can, but let's go ahead and get started. Said I will share this slideshow with you so you can work through. I'm going to kind of combine lessons 8 and 9 together in this one. So we're going to kind of jump around a little bit inside the workbook. I put the page numbers on top of the slide so you know where I'm at, and I hit the most important ones in here that I think that will benefit you guys the most, okay? So let's go ahead and get started. So what we're going to do today is we're going to solve some more problems about proportional relationships, and we're going to develop some methods for deciding if a relationship is proportional or not. All right. So just kind of get warmed up and started. I want you to go ahead and start and think about, this is on page 145, and consider the problem of a person is running a distance race at a constant rate. There's that word constant again. So a person is running a distance race at a constant rate. What time will they finish the race? So what information would you need to be able to solve a problem like this? So just kind of think to yourself. We're going to get more into how to justify some of our answering, how to come up with some reasoning skills and everything else. So this is kind of what this is going off of. So I just want you to pause the video for a moment and think about it to yourself. What information would you need to solve this? All right. So what information would you need? Why did you need that information? And based upon the stuff that we give you, do you have enough information to solve the problem yet? As of right now, we don't even know what the problem is. So when you start thinking about some information, if you start jotting down some ideas of information that you might be needing, was that still enough information? So those are some of the things that we're going to look at and take away, hopefully, after today's lesson. So let's go ahead and get started. This is on page 138. And what it says here, if you remember a couple days ago, actually I believe it was last week, you were working on converting some meters, centimeters, and millimeters. And now we're going to convert some other conversions. And this one's where we're converting from Celsius to Fahrenheit when it comes to temperature. So on this first question, it kind of gives you the equation there. And you're going to use that equation to plug in the numbers to come up with what temperature Fahrenheit it is based upon the temperature in Celsius. So I'll give you a moment to go ahead and fill that out. All right, so how are we doing this? So when we're looking at it, it's F equals 9/5 C plus 32. Okay, and you can go ahead and plug those in if you want to. Basically, you're just substituting C. You're substituting like this number here for C. So to try to give you a little bit of an idea of what that's going to look like, I kind of created a little thing here to kind of show with that. So we have our original equation, F equals 9/5 C plus 32. And then we're going to plug in, based upon that table, everything that we need. So when we're looking at the table, it was 20, 4, and 175. You can use your calculator to do this. So the first one, we were plugging in 20. The next one, we were plugging in 4. And then we're going to plug in 175. Over here, you can see kind of what those come up with. So when we're looking at our table, it should be 68, 39.2, and 347. So all we did was we took the number here and we exchanged it for C, and we did the math on that. So basically we just took this number, took out C, and we replaced that with it. So hopefully that makes sense. It's not something we haven't really not done this. We've worked on this a few times. Okay, so let's look at this next one and see if we can figure out that one. So use the equation c equals 2.54 n, where c represents the length in centimeters and n represents the length in inches. I know this was a question that a few people came up with the other day when we were converting centimeters to meters and centimeters to millimeters. What about inches? So here's one of those examples. Right? So go ahead and use a calculator. Inches is going to be n, centimeters will be c, and we're just going to plug these numbers in for it. I'm going to kind of did the same thing here. So you can kind of see it happening. So that first number we had was 10. So we're just plugging in 10. And you can see the answer come out there to the side when I do so. Next one, we're plugging in 8. And lastly, we're just plugging in 3.5, 3.5. So as you can see, we come up with 25.4, 20.32, and 8.89. So lastly on that, it asks a question as, are these proportional relationships? Explain why or why not. But when looking at these, let's go ahead and write them in real quick. So we have our numbers here written in. So when we're looking at it, we can look at these equations and tell if they're proportional relationships or not. Is there just one multiplier? Can we multiply 20 by anything to get 68? Well, we can. But with that same number, could we multiply 4 by to get 39? Or 175 by to get 347? So let's check it real quick. What's 68 divided by 20? That should be like 17/5. Then let's say if we did 39.2 divided by 4, we get 49/5. So it's not the same. So we know that one is not proportional, right? So this one is not proportional. But look here. We took these numbers and we multiplied them by the same multiplier, which took it multiplied by 2.54. So we can look at these equations very quickly and tell that this one right here is proportional. Since this one has this little plus 32 out there, a little plus 32 is what makes this not proportional. This one doesn't have the little plus 32, it just has the multiplier. So the second example is proportional. All right. So moving on to the next one, looking at page 139. So on this one, I'm just going to kind of get you guys started in the right direction on this. So when we're looking at this, how many edges are there on this cube? So count these edges real quick and see if you can come up with it. All right. So we have 1, 2, 3, 4. We have the same thing in the back with 1, 2, 3, 4. And then we have these sides. 1, 2, 3, and 4. So 4 in the front, 4 in the back, that's 8, plus these 4 around. So that's a total of 12 edges. So how long is one edge? Well, we're given that in the next problem. So what about faces? How many faces do we have on this? So it's kind of like a die. We know that dice have how many faces? Just a traditional die, not like a Dungeons and Dragons dice or something like that. So we're going to have what? 6, 1 in the back, 1 in the front. That's 2, 3, 4, 5, 6. So you have a total of 6. How large is one face? And we're going to give some measurements in a moment, and we're going to have to figure those out. So let's go ahead and try that out and see what happens. But remember, how many faces are there? Is there 6? And edges are 12. That's going to be important coming up. All right. So here's those cubes that you see on page 139. So you're going to complete each table that we're going to be dealing with in just a moment. And you're going to make sure you're going to be able to explain your reasoning on this. Kind of like what we talked with the warm-up. We're going to talk all about how to justify things. We're going to focus on that a lot because just like anything else, the main thing math teaches you is to be able to justify, is to answer that why question, is keep on teaching to ask that why question, but it's really also helping you teach you to answer those why questions. So, all right. So here's those next tables. So we have table 1, table 2, and table 3. So let's go ahead and get started. I'm going to help you get started on this, but I'm not going to finish them for you. So just to kind of give you a hint, remember, there's 12 total edges, and there's 6 total sides when it comes to this, right? So go ahead and look in your book, look at those sizes that they're talking about. They're listed down here at the side also, and see if you can figure out these tables. Okay, like I said, I'm going to get you started on it. Sorry for that noise. I hit my microphone. So, how many edges? There's 12. And we're saying that that first die, or that first cube, each length of the side is going to be 3. Well, how many total edge lengths is there? Well, if each side is 3 and there's 12 of them, we just simply multiply that by 12. So we come up with 36. Okay. So if we were trying to figure out this, it'd be simply for an equation, it'd be what? It'd just be S, it looks kind of like a 5, but it's S times 12. There you go, looks a little bit better. S times 12, because 12 times 3 is 36. So go ahead and fill out the rest of this. But let's go ahead and I'm going to get you started on the other ones. So on this one, what is the surface area of the cube? So if you remember how to do surface area, so if you had a square and each side was 3, how would you figure that out? So just be 3 times 3. So the surface area of one side would be 3 times 3, which is equal to 9. Notice it's also, we could write that as 3 squared. Look, it looks like a square, and we call that 3 squared. That's actually basically the reason why. So each side is 9 units. And how many sides is there? Well, there's 6. So 9 times 6, and that comes up with 54. So take this and fill out the rest of this, and then see if you can come up with an equation for it. Okay. Then lastly, it's like, what is the volume? If you remember how to do volume, see if I can draw myself a cube here. I figured you guys might be missing some of my artwork, so I'll go ahead and do it here. And this is 3, this is 3, and then the depth is 3 also, right? And it's the length times the width times the height. So all 3 sides together, the same thing as 3 times 3 times 3. We can also rewrite that since mathematicians are lazy. And we want to try to find a shortcut. What's 3 times 3 times 3? Well, we could also call that 3 cubed. It is no coincidence that this is a cube, and we call this 3 cubed. So when we have an exponent that's 3, it's called cubed, simply for this reason right here. It can kind of be like the volume. So what is 3 times 3 times 3? Or 3 cubed? And if you guessed 27, you are correct. So see if you can figure out the rest of those. All right, hopefully you had time to figure out the rest of those. So we'll go ahead and move on and see if we can answer these next questions. And it says, which of these relationship is proportional? Explain how you know. Well, from what I could tell, the side lengths is proportional. This one right here, because if you noticed, this one, when we were doing our equation for it, it was just s times the number over here. Remember, it was 12. There's 12 edges, so it was s times 12. So everything was multiplied by the same thing. All the other ones, there wasn't just one common multiplier to be able to do that. So those were not proportional, but this one was. Can you give me any other reasons why it would? So that kind of explains how I know. So let's go ahead and write the equations out for those other ones. If you did not get them, we'll go ahead and put them up here on the screen for you. All right, so there's the equations we came up with. So E is equal to 12 times S. So S was the length, and this is our equation. There's 12 edges. Area on that one for the cube was 6 sides times the length squared, because the area is the length squared. Multiply that by 6 to get your total area of that cube. And then volume was just the length cubed, so S cubed. So hopefully you got those same equations. But you can also look at these to tell which one of these is proportional. All these have this extra step on there, opposed to just a single multiplier. And if we go back to the thing that we were doing earlier, we can actually look at the graphs of these numbers and be able to tell if they're proportional or not. Because one thing about proportional is it goes through the origin. This is that first one we were doing right here. F is equal to 9/5 C plus 32 on that temperature conversion. It does not go through 0, 0. So this one is not proportional. But then when we looked at this next one, this one does. So it keeps the constant rate no matter where we go on it. It is proportional and it goes through the origin. So, all right. So carrying on. On page 147, it starts off with moderating comments. And it says a company is hiring people to read through all the comments posted on their website to make sure they are appropriate. 4 people applied for the job and were given 1 day to show how quickly they could check comments. Kind of break some information down here for everybody. It says person 1 worked for 210 minutes and checked a total of 50,000 comments. Person 2 worked for 200 minutes and checked 1,325 comments every 5 minutes. Person 3 worked for 120 minutes at a rate represented by C equals 331T. Sorry about my dog's barking in the background. Where C is the number of comments checked and T is the time in minutes. And then person 4 worked for 150 minutes at a rate represented by T equals 3 over 800C. It sounds really confusing, I'm sure. Seems like there's a lot of information, but yet some of you probably think that there's not enough information to figure out these next questions. But let's take a look at it and see. So what is our questions asking us? So the first question is, order the people from greatest to least in terms of total number of comments checked, and then order the people from greatest to least in terms of how fast they checked comments. So when in doubt, draw it out. How can we draw it out in this scenario? If you guessed table, you're probably right. So, you know I love me some tables. So I went ahead and created one here for everybody. That way we can kind of look at it and see. Hopefully this will clarify a little bit of what it's asking. So it says right here, let me see if I can make these a little bit bigger numbers, just so maybe you can read it just a little bit better. All right. So I put down the information that it gave us, and then I put out to the side some of the other information that it gave us that wasn't as user-friendly when it comes to the table. So first column, we have person 1, 2, 3, and 4. We have the time taken in minutes that they were each given. That was in that information. And then there's a couple things that I know the question is asking us to do. And the first question is total of comments, because we need to order the people from greatest to least in terms of total comments. And then the next thing we needed to do was to see how fast they check the comments and order those people from the how fast they do it, from greatest to least on how fast they did. So I went ahead and created another column for that. All right. So how are we going to figure this out? So the first one, go ahead and try to figure out this table. This is not in your book. This is just something that I created to try to help visualize what we're trying to come up with. But we can kind of see how many comments per minute. If you want to draw this table out, I would suggest it. How would we do this? Okay, if you guess you divide the 50,000 comments by 210 minutes to get your number of comments per minute, you are correct. We're trying to find that unit rate, right? So we're coming up with 238.1 comment per minute. For every minute, this person was able to read 238 comments per minute. That is pretty crazy. Some of you guys might be able to read that many comments on your social media post. I'm sure you can almost watch that many TikTok videos in a minute. So, but let's see if we can continue on. All right. So, what's this one saying here? Person 2 took 200 minutes, and then it gave us this other information. It says 1,325 comments every 5 minutes. So it's not quite as easily converted, but it is giving enough information so we could do this. So how would we go about doing that? All right. You said you would take the unit rate of this again and do the 1325 divided by 5. You are correct. And that would come up with 265 comments per minute. Pretty impressive. No way I could read that many. So, how many total comments is that? How would we figure that out? All right. If you said we were going to multiply 200 times 265, you are correct. So we have a calculator. Go ahead and check that out. It should be 5,000 or 53,000 even. That is a lot of comments to read. Well, here it already broke this down because it said rate of comments for 331T. All right. Well, if T is time and C is comments, then that is actually giving us our unit rate right there. So if T was equal to 1, if we plugged in 1 right there, what would that be? So 1 minute would be 331 comments per minute. So the same thing there. We're just going to take 120 and we'll multiply that by 331. And that's going to give us 39,720. So if somebody wants to go ahead and double check on the calculator, make sure I didn't mess anything up, that'd be great. All right. So what about this last one? Well, it looks very familiar. It looks very similar to this one, but it looked like they switched those variables around, right? And then all of a sudden we have this weird thing going on here. So what happens when you flip the variables around? You have to do that reciprocal of that constant in proportionality, that multiplier. But we can probably figure it out from this. See if we can figure it out from here. So one thing you can do is, if you're looking at this, you're just going to plug in 150 minutes in for T, and you should be able to come up with the C. So you plugged in 150 for T, it's going to be T equals 3 over 800 times C. I kind of put that in here. You notice it doesn't calculate it automatically for you, but you can kind of look at this equation this way. What do we need to do to get the C by itself? What are we doing right here? That's multiplication. So what's the opposite of that? So what we would have to do is divide both sides by 3 over 180. So what we can do is just divide 150 by 380. All right, looks a little weird, but 150 divided by 3 over 800 would give me 40,000. So we can plug that in. Just kind of show when we're dealing with reciprocals, we could have flipped that over and went 150 times what's the reciprocal of 3 over 800, and that's 800. All right, so we can plug in 40,000 here. We still need to figure out this number, and that's just 40,000 divided by 150. And that should be 226 points. So I would pause this video for a moment, and that way you can figure out which one is in order for both question 1 and question 2. All right, so hopefully you figure those out. So kind of just as wrapping things up here is something to think about before we leave and have you do the cool down. What are some situations that we have seen where quantities were proportional to each other? Think about previous lessons, think about this one. Which ones were proportional and which ones were not? When are we in a situation where we have a proportional relationship between two quantities, what information do we need to find an equation? I need all those things involved with it, right? We kind of went through multiple different scenarios, the last example we ran through. And how can we decide if a proportional relationship is a good representation of a particular situation? We're going to get more into this later on, but just some good questions to think about. Equations are good tools to make predictions or decisions. When and how did we use an equation to make a prediction or a decision today? All right. Hopefully that's leaving you thinking with some examples and everything else going forward. So these are the things that we kind of did today. Is I can ask questions about a situation to determine whether two quantities are in a proportional relationship, and I can solve all kinds of problems involving proportional relationships. So we got pretty complicated today, but we've worked our way up there over the last couple of weeks. Hope you're not too lost. Hopefully it makes sense to you and everything else. So kind of wrap it all up. Go ahead and do this cool down. I said this should be in Google Classroom. You're going to click on the cool down called 10/13/2020 cool down 7.2.7, 8, and 9. Like I said, I kind of combined multiple cooldowns into one. That way you're not duplicating a whole bunch of work. And also for anybody who already took this cooldown, please go ahead and take it again. I have erased all the answers, so you should be able to take it again. So I know some of the grades were not that great in there, especially since we did not go over all the information. So this is the one that has the tables and chairs on it, if you've already seen that. But go ahead and take this cooldown, and I'll see you when I see you. So until next time, good luck, guys. Keep me posted if you need anything. Have a good day.